All right, hello, Science 10, Mr. Beeland here. We are talking about the transfer of thermal energy, right? How does the thermal energy move from one thing to another? There are three different ways that this happens. It is conduction, convection, and radiation. Okay, so starting over here, conduction. This is similar to when dealing with static force. Transfer of thermal energy, TE for thermal energy, by direct collision of the particles inside matter, right? So the particles are hitting each other, or they're in contact with each other, and the heat is transferring across. This can happen, so this occurs in all states. So solids, liquids, and gases. But metal, solid metal, is common, right? All of our oven, pans, pots, anything like that, right? They're made out of metal, direct contact. So that is actually a good example. We could have our pot. Here's our pot. And it is on an element that is heating up. Direct contact with the metal is what's going to heat up the pot. Okay. The next one is convection, which is the transfer of thermal energy inside a fluid. Now, fluid means liquid or gas. And this is done by the movement of warmer and cooler fluids from place to place. So what you'll see here is, for example, if we have, again, I'm going to draw our pot here, and it's full of water. We're trying to boil some water. What will happen is, because the heat is coming from down here, right? The hot water will move up to the top, and then it will start to cool as the heat comes off of the top. And when it gets colder, it will go down, right? So you get this constant cycle, the convection cycle, okay? So hot rises, cold drops, and it will continually rotate there to consistently warm up the whole container. Again, this can be in liquids and in gases. It's also very common in, for example, the Earth's molten crust, right? Or sorry, the molten core. Right? There's a convection cycle that's happening there, right? It happens in boiling water, it happens in the air that we breathe, it happens everywhere with fluids. Okay. The last one is radiation, and this one takes place with gases, right? It's very important with gases. This one is the transfer of thermal energy through electromagnetic waves, okay? So what does that mean? Well, that is basically how fires work, right? A campfire. You could have a person, right? Here's your person sitting at a campfire. I know it's a blue fire, but bear with me. Okay? They're not directly in contact with it, right? So it's not going to have conduction. And there is not any way for this, you're not a fluid, you can't be part of a convection cycle, right? So what's happening is the electromagnetic waves are coming off of the fire, and that is what's warming you up. Okay, so these are our three types, right? Conduction, convection, radiation. One other thing to note too is something called an insulator. And this works very similar to what you would have seen an insulator do in your electricity units from the past. An insulator, change that. An insulator is a material that heats up slowly. Basically what they're saying is an insulator is something with a high specific heat capacity, right? So high specific heat. It takes a lot of energy to warm it up. It doesn't like to warm up easily. And once it's hot, it takes a long time for it to cool down, right? So some examples. Wood, right? It does in fact take a lot of energy to get wood to catch on fire. And once it's on fire, it's very difficult, especially if it's a large piece, to go out. Some plastics, fiberglass is very common. And even the air can be a good insulator. This is why greenhouses can work, right? Because the air stays hot inside the greenhouse. So as long as all the air stays contained, which is what the canvas is for, then all the heat will stay inside. Okay, so major takeaways for this, right? 3 different types of transfers of thermal energy. You've got conduction, convection, radiation. Make sure that you can identify which is which in a given scenario, as well as be able to identify what states of matter can this take place in. And then finally, we have our insulator. We're taking that term from our electricity from last year and we're applying it to this year. Does basically the same thing. It doesn't react quickly, or it doesn't change quickly, right? Okay, that's it for today. Take care.